Launched on the 25th of December, 2021, the James Webb Space Telescope, also known as Webb in short, has the primary objective to fill in our knowledge of how the universe came into existence. Although the Hubble Space Telescope has completed a tenure of 31 years since its launch and is predicted to remain operational till 2040, the Webb is considered as the successor of this legend. Just as a thumb rule, the size of the mirror of a telescope corresponds to the amount of light or details that will be captured in the image. If we compare the Hubble and the Webb, the Hubble has a tiny 7.8 feet diameter mirror, compared to the 21.3 feet gold-coated mirror of the Webb. Due to the sheer size of it, it is supposed to have a magnification of almost 100 times that of Hubble. To give you a clearer idea of what we are talking about, this was the image taken by the Hubble, famously known as the Deep Field. You see, telescopes are not just huge magnifiers, they receive light from unimaginably vast distances. Which means light received on the mirrors of these space telescopes is from the past. Just like it takes 8 minutes for the light to reach Earth from the Sun, the light coming from these sources are millions of years old. So basically, these are tiny windows, offering us a view in the past of our universe. So how far back can we see in the past? With the Webb, about 100 million years. That means we would be able to see the state of the universe when dinosaurs roamed the Earth's surface. This is made possible due to the nature of Webb to see in the infrared spectrum. You see, red color is used as a signal for warning, because it can travel a longer distance before being dissipated. This happens due to its wavelength. Infrared has an even longer wavelength than red, thus can penetrate large distance through space, overcoming barriers such as stellar debris. The Webb telescope is, just like us, situated close to the biggest infrared emitting object in the system, that is the Sun. So how do we prevent the Sun from messing around with the data gathered from the telescope? You see a few sheet-like structures underneath the telescope. Those are layers of heat-dissipating shields. The telescope works at a temperature just a little above 0 Kelvin, so that almost all the background infrared radiation is cut out from reaching the sensor of the telescope. As of now, scientists strive to shed more light on the formation of stars and planets. We know that stellar gases collapse under their own gravity and form stellar objects. But we are still not sure about the exact mechanics of these creations. What did the first galaxies look like, and how did black holes form, and does every galaxy have a supermassive black hole at its center? Are there other planets like Earth which harbor life in them? The tennis court-sized space telescope will also help researchers understand dark matter and dark energy more. But what role does Webb have here? There is something called the gravitational lensing, where large stellar masses like a cluster of galaxies, due to their sheer mass, are able to bend light, just like black holes. What else bends light? You guessed it, lenses do. So depending on the mass of the gravitational lens, the amount of bending of light can be predetermined and again observed by the Webb in real time. The hypothetical amount of bending will depend on the observable mass, whereas the real-time data from the Webb would include values for the dark matter as well. Thus, if we subtracted the hypothetical value from the experimental value of the mass of the galaxy cluster, we will get a precise value of amount of dark matter present in a specific location in space. The observable universe is just 4% of what exists. The James Webb Space Telescope will probably make a tiny scratch on the surface of space exploration, but that's one small step for man, one giant leap for mankind. Thank you for watching Explified. We hope you learned something new from the video. Let us know in the comments what you think about the James Webb Space Telescope and if you are excited about the first pictures of the space after calibration. Like, share and subscribe to our channel. Check out other videos on space and travel on Explified. See you in the next one.